Okay, so hey everyone. In this video, let's talk about a system design problem. So let's suppose if you are sitting in an interview and you have been asked to design a user availability system. Then how would you design the system? How would you make it extensible? How would you make it scalable? We will going to be talk about all these things. So if you want to design the system by your end, first pause this video and design. Make it as much as scalable you can make it, and then pause this video. Okay. So I'm starting with my solution. Okay. So when we are designing the system, what things we would have in our system, what components we would like. So I can say, hey, I would definitely have a client, right? Client is the person who will make the request. Okay. Now from my client, I would make requests to my servers, right? And on the servers, I would have my backend will doing all the work. But let's suppose you have a very huge number of traffic. Then it would be great if you can distribute your requests to multiple servers, right? And if we are distributing our requests to multiple servers, then what things come first? We can say, hey, we can use a dynamic load balancer in this, right? We can make a load balancer which would help us to solve this problem. So here is my load balancer. Okay, guys. Now once I have my load balancer, what I can say, hey, let's make some servers. My load balancer can call to any of these servers corresponding to requests or whatever the request is. Okay. So let me make or this is server one, this is server two. Okay, this is server n minus one, and this is server nth server. So let me just write this is my server one. This is this is my server. Yeah, this is my server two, and I can say this is my server n minus one. Okay, and then I can say this is my server n. Got it. Now, once we have done with this, what I can say, all my servers would redirect my request to my backend, right? So let gather all these requests to a backend for simplicity. So okay. Now here I would have my backend. Okay, let's make it backend. So backend. Okay, cool. Now here things come. First, what is the efficient way to check whether a particular username is present or not? What does this mean? It means whether a username has already been taken up or not. We have to check this. So if I just talk about some possible ways, then what are the possible ways of this? We can say, hey, the first is I can call DB. Okay. But if I call DB, then uh, how you would optimize your query? You can say, hey, I can simply do linear search, which would take off and time complexity. But if I do so, then I have millions of users, right? If I do the same, then it would be a very expensive test I call, right? And it would eventually shut down my DB. It would crash my DB. Okay. Then you would say, hey, let's do one thing. The another way is let's do indexing. If I do indexing, then now the time complexity of searching is off login. Okay. I say, okay, makes sense, makes sense. But if I okay, if you also say let's do one more thing along with indexing, let's do indexing plus sharding as well. I can shard my database based upon the usernames. I can use any sharding algorithm, any consistent hashing algorithm to shard. Okay. So now in that particular case, I would have at least log and time complexity to search for every query. And I'm assuming I'm getting millions of queries. Now just think if I'm getting millions of queries and for each query I'm calling my DB. And even if it is taking login time, then it's still very bad. Okay. Because database are not that much capable to do millions of operations within minutes, seconds, or any particular time unit, right? This is very expensive disk, I call. So what is the best way? Uh, let's think something in terms of Redis, or like here you have to be know about the Sunbloom filter concept. Okay. What I can say let's do one thing. Uh, After my backend, I can simply call Redis Bloom filters. Let's call Redis Bloom filter. Okay. So this is my Redis Bloom filter. Redis Bloom. Okay. Now Redis Bloom filter, we know Redis Bloom filter is a probabilistic function. That means what Redis Bloom filter says, hey, if I am a Redis Bloom filter, I can guarantee that this data is not present in a set. But if I'm saying, hey, this data can be present in a set as a 50-50 situation. Guys, because we know Redis Bloom filters जो है, that works uh, on bits, right? The internal structure of Redis Bloom filters has bitwise array. So now you can just think of, let's suppose there was a username came A, B, C, D, E. Okay. And our Redis Bloom filters assign this username, like distribute this username with certain number of bits. Let's suppose bit 1, 2, and 4. Okay. And initially this username was taken up by someone. So Bloom filter marked it true. True, true, true. And let's suppose there is another username came B, D. And Bloom filter says, hey, this bits, the corresponding bits of this BD is 1 and 4. Now we know 1 and 4 is already marked as true earlier, right? So, but I'm not sure if BD is present or not, right? So in that case, we need something which can tell us correctly. So let's suppose I can say, hey, if my Bloom filter is saying data is not present, data is, I can say, username is not present, return the response. Return response. Cool. But if Redis Bloom filter says, hey, it is a probabilistic situation. So what I can do? Okay, let's go. Let's go further deep down. And I can say this is probabilistic uh, case, right? Now here are two things. Either you can directly call your DB, because now we have, since we have used Redis Bloom filters, so we have maximized, or I can say we have reduced the number of calls that was earlier coming into our DB, right? But I would say let's add one more step. I would say let's add a Redis here. Let's add a Redis here, and this Redis could store a given username for 24 hours time will. So I would say Redis all username. Okay. If my Redis say, if there is a username present in my Redis, that means that username already exists in my DB. So if we get a condition of cache hit, then I can say, hey, we got the response, username is present. So I can simply say this is a cache hit condition. Cache hit condition, return response. But let's suppose if this is a condition of cache miss, or let's suppose if this is a condition of cache miss, then let's go further. Or this is a condition of cache miss. Now, if this is a condition of cache miss, then what we can say at last? Okay, if this is a condition of cache miss, then now call our DB. I would say DB database shard, database specific shard corresponding to that username. And if it is present in my DB, return the response that hey, this username is already exist. But if it is not present in my DB, then return the response, hey, this username is not present. So I'm saying, let's make a call and say return response when username doesn't exist. But let's suppose if username is already exists, then what we can say? The username is already exist. Then we can simply say, mm, the username is already exists. Then we can return the response, right? So I would say, okay, let's do one thing. If the username is already exists, I'm saying if the username is already exists, so just return the response, okay, because because username exists, okay. But what if username does not exist? Now, if username does not exist, that means that person can take the username, and apparently we have to put it into our Redis and we have to update our Bloom filter as well. Now, here two things come. Either the Redis updation operation or Redis Bloom filter operation, you can make it asynchronously, or else you can make it asynchronously. What is the best option? Of course, asynchronously. So now I can say, uh, I would have SQS over here. This would be my SQS call, a simple queue that would eventually update, uh, that would eventually update in my Redis. So I can say update username, username taker, username taker. Okay, update in my TV, uh, update in my Redis. Okay, Redis with 24-hour ATM. Along with this, do one thing. Also update in my blue filter as well. Okay, if you're confused why we are doing this operation asynchronously instead of synchronously, then just wait, I'll explain. So let's update username taker in Redis. Okay, okay. Now let's just talk about why it is better to do this asynchronously instead of synchronously. Because let's suppose if when a person is taking the username, you do the updation in Redis and updation in Bloom filter synchronously, right? And apparently, let's say here, this is updation for Redis, this is updation for Bloom filter. And let's suppose any uh, any of these operation gets failed. Okay, DB gets updated, but after DB gets updated, any of this operation gets failed, any of this updation operation gets failed, then ultimately your API would return an error, and eventually you have taken up a username here, right? That's why it's better to use asynchronously. Like we would have a simple messaging queue SQS. Consumer would take the event and apparently it would update simultaneously or later on. Even if we are getting any error while updating in Bloom filters or Redis cache, then it's totally fine. Eventually it will retry and update it. Okay. Now the last thing is you must have been wondering why I've edit this Redis cache for 24-hour TTL. The reason is pretty simple. Let's suppose there is an internet that is going viral. I'm sorry, there is a trend that is going viral on internet, right? And if a trend is going viral on internet, then a lot of people will try to take a username corresponding to that trend, right? And ultimately, we would receive a bunch of requests corresponding to similar kind of usernames, right? So why we should make our database more loader, right? We can simply use Redis for this, and that's how eventually we can save many, I would say, redundant, expensive network IO calls. Okay. Yeah. So this one is also clear. Yeah, that was pretty. That was all the thing that I wanted to talk about, and yeah, that's how you can solve this problem. And this system design can easily handle millions of users' traffic, and out, and eventually this is a over design of the problem. I have over designed the system, but I would say it is better to over design the system rather than to under design, because ultimately if you receive very heavy chunk of traffic at any point of instance, then your system should be enough handleable, right? So yeah, thank you for watching.